Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. I do hope you are doing well. Now, in this lesson, we are looking at the set theory, the basic concept in set theory. Specifically, we'll be looking at the universal set, subset, and the proper subset. So, without much I say or do, let's quickly look into it. Now, to start, since we are talking of set, there is a need for us to know what a set is. So you see, a set is a collection of distinct objects or numbers. Okay, a set is a collection of distinct objects. So for instance, you can write something like this: A, then you have 2, 4, and then 6. Right? So this is a collection of distinct objects. As you can see, all these elements here are what distinct. And I have used a capital letter to represent them. In addition to that, you look at the brackets I've used over here. These are curly brackets, and they are the type of bracket we use to what? Enclose set. Now, each member in the set is called an element. It is called an element. And with that, we say an element is an individual item within a set. An element is an individual item within a set. If you want to denote that a particular element is within a set, for instance, you want to show that 2 is in set A, 4 is in set A, and then all that, we use this symbol over here, which means an element of. So I can say 4 is an element of set A, which means our 4 over here is inside the set. On the other hand, since we don't have 5 there, we can say 5 is not an element. So it's not that element. All you do is you cancel it out. 5 is not an element of set A. You see, these are just some basic notations we need to know in order to work with set. With that said, let's look at the universal set. So talking of the universal set, it is the total collection of all the elements relevant to a particular problem or context. If you want to solve a question, the combination or the collection of all the sets that we'll ever need is what we call the universal set. Okay, so what it does is it is a container, and then it holds all the other sets being discussed. For instance, if you are talking of even numbers between 1 and then 10, and then odd numbers between 1 and 10, and then let's say prime numbers less than 10. If we want a set that will contain all of this, then we'll say the universal set represented by U. So our representation is U, is then going to be what we see on the screen, right? So a set that contains from 1 to 10. Then out of this, we can say we are talking of even numbers less than 10, odd numbers less than 10, prime numbers less than 10, composite numbers, and all that. They are all contained here in this set. And that is what we call the universal set. The next thing is what? A subset. So talking of subsets, first of all, before we look at what it means, let's take a set A. So I'll take set A to be having the element 1 and then 2. And then I'll take set B also to have the element 1, 2, and then 3. If you look at the two sets I have critically, you realize that if I take set A and I put it here, it means all of set A's elements are inside set B. That introduces us to what we call a subset. So set A is a subset of set B if every element in A is also an element in set B. And we denote it as what? A is a subset of what? Set B. This is the denotion over here. Now, there is this symbol and there is also this symbol over here. What does these two symbols mean? Once again, let's take these two sets over here. And this time around, I'm going to let set A be having the element 1, 2, and 3, and set B have the element 1, 2, and 3 as well. Now you would realize that if I take set A once again and I compare it to set B, all the elements in set A are also in set B. You see? And then it is even equal to it as well. That is where we use this element here. So this symbol here. So it means A is a subset of set B, all right. And in fact, it is also equal to it. So the down here is for our equality sign. That is the difference, the only difference between this set and then this set. With that said, we have something we call a proper subset. A proper subset. So for a proper subset, all the elements in set A are in set B, but they are not equal to it. You see, they are not equal to it. So before we look at the definition, if you look at the two we considered, set A and then set B, you'd realize that this set over here is actually a subset of B, but it is not equal to it. On the other hand, this set A over here is a subset of B and it's equal to it. So if the set is a subset of set B or the other set, but not equal to it, it is a proper subset. You see, that is what we call a proper subset. So set A is a proper subset of set B if A is a subset of B, all right, and A is not equal to B. You see, so this means that B must contain at least one element that is not in A. So if you compare this set and then this set, B contains this element and it is not in what? A. That makes it a proper subset. So all the sets in A are not exactly a photocopy of that in set what? B. That is a proper subset. And this is the notation for it. So you write the normal subset symbol and then you put not equal to over there. These are the basic concepts we need to know to enter into what? 2 and then 3 set problems. Now, as usual, let's solve some examples, after which I give you some for you to try to test your understanding. So our first question here says, let set U. So this here is our universal set. So let U be 1 to 7, and then A is 2, 4, 6, B is 4, 6, and then C 5, 6, 7, and 8. And we have to use the correct symbols. So this is the normal subset, and then this is the what? The proper subset. So with the normal subset, we know this can be here or not. Okay, so with that, we can say that if you want to describe the relationship between set B and then A, what is happening here? Take a minute and then look at it critically. You see, so first of all, let's check for subsets. Are all the elements in B inside A? Are all the elements in B inside A? Well, there is 4 over here and there's also a 4 here. There is 6 and then there's also a 6 here. So with that, what can we say? We can say that set B is a subset of set A. So first of all, we have established the fact that it is a subset. Now let's check if it is a proper subset. So is set A having an element that is not in B? Yes. And certainly set B is not equal to set A. Hence, we can also say that what? Set B is not only a subset of set A, but then it is also a proper subset of set A. So this would be the correct symbol we are going to use. That is the proper subset symbol. And I do hope it is clear. Okay, so let's look at our next example. Now, for this next question, we are still using this same set of sets over here. Okay, so we are still letting our U be this A and then B and C. After this one, I would explain something we call the number of subsets. So please stay tuned. Now, we are to state whether the following statements are true or they are false. You have to state whether they are true or false. So first of all, is 5 an element of the universal set? That is, do we have 5 in the universal set? Yes, 5 is in the universal set. So for A, it is a true statement. Then the next one is set A a subset of the universal set. Yes, it is a subset because the 2 is found in the universal set, the 4 is also found, and the 6, all the elements in A are found in the universal set. So then we can also say that is also a true statement. Then the last one, 8 is not a member of set C. It's not an element of set C. If we look at set C, don't we have 8 here? We do have 8. So that alone is a false statement because 8 is actually in set C. For our last question here, which I'll be using to introduce a new concept, it says list all the subsets of the set D, and D has the element P, Q, P and Q. So how many are there, and then how many are proper subsets? How many are there, and then how many are proper subsets? So generally, if you want the number of subsets of any set at all, we use the formula 2 raised to the power n. 2 raised to the power n. And we say the n is simply the number of elements in the set. What do we mean by the number of elements in the set? So for instance, if you take this set over here, and we want the number of subsets it has, then it will be 2 raised to the power n, where this n, we are coming to look at how many elements you have in the set. You have 1, 2. So 2 raised to the power 2. Then you evaluate it. If you want the number of subsets this has, then it's 2 raised to the power 3. 3 coming from the fact that there are 1, 2, and then 3 elements in the set. That is the formula here. You see, so the number of subsets a set has, the total number of subsets a set has, is given by the formula 2 raised to the power n. Now take note. First of all, we call a set without an element a null set. You see, and then it is represented by this. Or better still, you do your set, your curly bracket with no element in it. This null set we are talking about is a subset of every set. The second thing you have to note is that every set is a subset of itself. Remember the idea of what? Subset. So every set is a subset of itself. With these ideas known, let's go on to what? List the subset of our set we have here. So as we have noted, let's first of all write the null set, and then secondly the set itself. So the set itself, which is P, and then Q, and then we now take the individual elements. So we have P and then Q as well. And if you have to compare that to this formula, which is 2 raised to the power n equals the total number of subsets, then if you have to put our n, which is 2 over there, which gives us 2 raised to the power 2, we have 4. Then as you can see here, we have 1, 2, 3, 4. 4 sets, which are all elements, which are all subsets of set D. Now the question says, how many of these, how many are there? So it implies that there are 4 of these subsets. And how many of them are also proper subsets? Proper subsets. Remember, we said the proper subsets are those that are not equal to the set itself. So apart from the null set, this one and then this over here, this set here is actually equal to our set in question. Hence, it is not a proper subset. It is a subset though, but not a proper subset. So out of the 4, we then have just 3 that are proper subsets, right? So that ends the set of questions for this lesson. As usual, I'll give you some for you to try on your own. So here are the questions, and then there are just 4 of them, 3 of which are using the preamble you see up here. The very first one says what? If you have x y, and then z. Use the correct symbol to describe the relation between y and then z, which we've done an example. Then you have to state true or false whether b is an element of y. Then you list all the proper subsets of this set over here. And then finally, how many subsets does this set have? Remember the formula 2 raised to the power n. Yes. So that ends our lesson on the basics of set theory. If this is your first time on this channel, this is Hap Beyond Numbers, where we learn math the easy way. If you think this channel will be of help to you and you want to receive notification on subsequent videos, you can choose to subscribe. I do hope this lesson would be helpful. See you in our next lesson where we look at the 2 and then 3 set problem. Bye for now and stay safe.